Title of my dissertation is an intersectional examination of the trajectories of student science identity growth among secondary and post-secondary students. So I've been interested in science identity since I began, and in Dr. Fenster's quantitative research class, I was very blessed to have an AERA acceptance for my paper on student science identity there. And one of the graduate students that was in my roundtable discussion had written a paper on unbecoming a science student. And that really interested me. I thought she was such a unique thinker on what does the trajectory of student science identities look like. So one of the things that I've discovered in this doctoral program is I love writing, and I hope I will be able to continue to write after graduation. Huge thank you. I have the most wonderful committee. Thank you to Dr. Fenster, whose just guidance and support and wisdom has been invaluable. To Dr. Van Mecke, who's a subject matter expert and Notre Dame grad. And Dr. Johnson, who has just been so great and really helped me with my writing and just overall presentation of a dissertation. Thank you so much. So the problem that the study addresses is the insufficient number of students in the American STEM pipeline. Noteworthy, this is a global issue, not just confined to the United States. The rationale is to examine the development of student science identity at the intersection of race, gender, and SES and school control. So social identities are unique for each student and their social constructs. And student science identity is recognized as a highly effective predictor of STEM persistence. So the purpose was to investigate the longitudinal trajectories of student science identity from the beginning of 9th grade and secondary school until 3 years after graduation from secondary school. And we used data from the National Center for Education Statistics, High School Longitudinal Study of 2009. Oh, how did I do that? All right, so let me just make sure I'm in the right spot here. So it addresses several gaps in research. The motivation behind changes in student science identity development really lacks clarity. There's a need for more research in that, as well as using an intersectional lens to examine these changes. There's also a need for more research on the association between socioeconomic status, SES, and science identity. And there's minimal research on school control, the role of school level predictors on the development of student science identity, and even less on how student science identities are distributed between different types of schools. And HSLS looked at public and then combined Catholic and private. The research questions are: how do student science identity trajectories vary across racial groups during this time period, secondary and post-secondary education? How do student science identity trajectories vary across gender groups during the same time period? How does the influence of SES on the student science identity trajectory during this time period vary at the intersection of race, gender, and school control? And how does school control influence science identity trajectories at the intersection of race, gender, and SES? The conceptual framework is based on student science identity as a predictor of STEM persistence. This is a recognition that students like science and know they can be good at it. It is related to persistence in a STEM discipline, which is really important, not just pursuing it, but also persisting in it. It's one of the many identities that are dictated by social construction. So it's influenced by the microcosms and the macrocosms where our students exist. So that being true, experiences such as those of a parent, a sibling, their peers whose influence becomes more salient in high school, their own science learning experiences are just some of the many factors that contribute to student science identity. The theoretical framework is intersectionality. It recognizes that there are many, many factors that play into the development of a student's science identity. The 4 that we examine in this study include race, gender, SES, and school control. So race influences student science identity in many ways. Some of those include the structures of opportunity that students encounter in school. Ethnocultural identity is known to have a negative influence on academic achievement as well. And there are stereotypes that are held by teachers and parents and others that can dissuade students from pursuing science when they find that they enjoy it, or discourage them from really developing a strong student science identity. The school environment becomes very salient as the students get older, peer influences, and membership in multiple stigmatizing groups can also really inhibit a student's development of a strong science identity. We know that socioeconomic status has a strong influence on student academic achievement and can lead to educational stratification. And then last, gender-based stereotypes are ubiquitous in science, and women face both horizontal and vertical segregation pursuing science. The methodology used is a non-experimental, descriptive, longitudinal, retrospective, quantitative research design, which we use to explore the racially and economically diverse secondary and post-secondary student data regarding over 25,000 students in secondary school through post-secondary education and work. That high school longitudinal study of 2009 provided this data, and this longitudinal approach enables a temporal analysis of the trajectories of student science identity growth, while also facilitating the intersectionality piece where we can look at race, gender, SES, and school control. The goal of the study was to make components of individual heterogeneity within the student population visible. So with that in mind, 2 different methods of statistical analysis were used. The first was gain score analysis, and used the percentage equation for that. That was chosen because students began at such different points when they entered 9th grade. Hispanic females began with only 32.7% of that population reporting that they had a positive science identity, as compared to Asian males, where over half, 55.4%, reported a positive student science identity. So to recognize the growth within each individual group, gain score analysis was used. And then the linear regression models were also used to recognize each variable while controlling for the others. Research findings. Student science identity growth trajectories dramatically varied across racial groups. So the trajectories of Black and Hispanic students of both genders were remarkably closely associated. And this was also true for the trajectories of multiracial and white students. Gender had a significant impact on student science identity growth trajectories. Non-Asian female students demonstrated the most growth during secondary education. Non-multiracial male students demonstrated the most growth during post-secondary education. So the research suggests that women have a tendency to grow more during secondary school. The male students grew more in their science identity during post-secondary education. Female students consistently reported seeing themselves as less as a science student than male students of the same racial group. The influence of SES on student science identity decreases over time, which I found very interesting. And the students in SES Quintile 2 are more likely to see a decrease in the influence of SES on student science identity than students in SES Quintile 3. The findings also demonstrate a positive association between student science identity and private school. And this positive association was more significant in the last wave when students were in secondary school. Study limitations. Oh gosh, goodness, sorry, I'm too heavy-handed here. I'm just trying to get my Zoom out of the way. So subject retention is always an issue in longitudinal studies, but the attrition between the first wave and the third wave 7 years later was only 7.5%. So I was really pleasantly surprised when I looked at that. So subject retention was excellent with the study. Small sample sizes were an issue for certain populations in private school. So for example, with Asian students with a low SES, for multiracial students, and in the bottom two SES quintiles, and for white male students in the second SES quintile, there were single digits in the sample size. For the most part, the sample sizes were very generous, but certain populations, it was extremely small. The reliability paradox, I think, is also a consideration, since students are asked the same questions over several different waves, and influences the way you process the question and answer it. It's a potential concern. It's difficult to lump science together because science disciplines are so different. Biology, environmental science, they're very literacy-based. Math and chemistry are very math-based. So it's most likely that students would have a variation in their science identity depending on that discipline, but they're lumped together in this particular study. We really know nothing about adult science identities and what that trajectory is like. So it's interesting that we really don't know what we're headed to. And also the timing of waves. One of the things that really surprised me in the findings was that it was consistent positive growth for all populations throughout all three waves. I was anticipating there might be a negative or a drop during some waves, but it was consistently positive throughout the survey. So I wonder if the timing of the waves was a little bit closer, if it might paint a little bit of a different picture of the identity trajectories of students. Conclusions of the study. So neither race nor gender alone was predictive of student science identity growth. Student science identity growth was inconsistent over the 7-year period for all students, with the exception of multiracial females. They had a 19% plus growth consistently throughout the survey. Female student growth in science identity tapers off in post-secondary education and work for many. Hispanic and Black male students showed the greatest growth during the post-secondary period. Asian, multicultural, and white students began secondary school with really strong student science identities, so that would suggest that they had a big growth period in middle school or earlier. Underrepresented minority students demonstrate a robust but latent growth in student science identities, which I wonder if that's not a piece of the puzzle that we face. For students that develop their science identities later, they are most likely not as prepared for those gatekeeper classes in the introductory classes once they pursue a STEM discipline. Asian and white students of both genders are more likely to demonstrate a positive correlation between SES and science identity than other student groups. SES may be less influential on the science identity trajectory of underrepresented minority students from the data. And public school students of both genders are more likely to demonstrate a positive correlation between student science identity and SES, suggesting that there might be an insulating factor in private schools. Interestingly enough, the private school advantage in student science identity growth continues and is even stronger in post-secondary education. So just going back to the theoretical framework, and the findings support the intersectionality framework. Student science identity growth trajectories, they vary dramatically at the intersection of race. Male and female students of each racial group demonstrated significantly or remarkably different trajectories. Gender made a very big difference in the growth trajectories, as did socioeconomic status and school control. In one way that I guess intersectionality wasn't supported is that the rankings as far as the male students of that racial group are consistently higher than the female students of that racial group throughout the study. But it supports that educational inequalities result from structural social inequalities. Suggestions for future research, a longitudinal study with more waves, and definitely with more private schools included would be very valuable, because the sample size for the low SES quintiles in private schools were often extremely small. Definitely more research is needed examining the covariates in the student's home environment. An interesting study reported that parents support STEM interests equally for sons and daughters, yet they engage in STEM practices more often with sons. And the last thing that I feel really strongly about is that research is needed in post-secondary education to develop a second pathway to STEM degrees, one that's more inclusive for those students who have latent science identity growth. And thank you very much. I've loved the whole journey through Notre Dame. It's been wonderful. I've learned so much. And I was talking to Dr. Schneider on Wednesday about Sister Claire, and I channel my inner Sister Claire every day in my classroom. So I've just gotten so much out of the whole journey. Thank you.